Hello. I have no idea what I'm going to do on the Strafe client physics thing. I'll just give it a shot for 2 hours at least, as usual. What a nice song. I think I was looking at a graphic. The graphics. Uh, so it can't draw non-polygons. With thickness, it can't draw thick lines. So either I can make a thick line rasterizer. I've heard the song so many times. Gosh, I don't have a way. Yeah, it's kind of let me down. WGPU. I need to draw thick lines, and that's what I need to do. Is there a library? So I expect that this is done. Very centric. Oh wow. That is very much JavaScript. Just Rust. Ugh. What? They have a blog? July. Right. Every major GPU platform. What you working on today? I have this graphics demo here. Strafe. And what it does is it's my little game engine. And what it does is it highlights whatever I'm looking at. So I was wondering if I could use it to help me debug a misbehaving algorithm. Oh, that's wrong. It's not showing that. Wow, it really doesn't want to show that. Huh. Yeah, there's a start zone. You can actually see the start zone. Yeah, so what I need to see is the result of the closest point algorithm. So like imagine that I'm looking at the start zone, right? And I'm over here. What's the closest point on the surface of the start zone to me? Well, it's on the edge. So along this edge, I want to like highlight it and go like, oh, look at this edge. Because that's the closest point. And that's the output of the closest point algorithm. But I can't just draw a line. Except I kind of can. What if I just freaking do it and like lower the resolution so it's obvious? I'll draw it in like 640 by 480 or something. What if I do that? Plans for Xmas. I never have plans for anything ever. Yeah, graphic. What? How do I do this? Resize. Resize. Config. So, what if we just don't resize? I guess we need to resize once, but I'll just say 640 by 480. Let's go. What happens when I do that? That didn't work. It just kind of made it stretched. And it's still like HD, mega HD. Ah, okay. Yeah, no, it actually doesn't care. I forgot. Damn. Wait, no, isn't that wrong? Depth view, create depth texture. Yeah, I'm stupid. This is called right here. Oops. Okay, there we go. So set width and height. Bow. 640, 480. Bow. There we go. Okay, so if I just make it mega low res, then it doesn't matter if I can't draw thick lines. Let's go! So now, now when I draw lines, right, that is right here. Now it should be thick, and I can see it. Cool. Yeah, see, you can actually see it now instead of it being like you can't see it. I can't see. What about points? Line list. Point list. Your point list. Okay, yeah, you can like kind of see it. Can you see the point like there and there? I feel like I could go even lower res. This is not terrible. How I gotta like make it nearest neighbor. It's like wacky scaling. Is that the compositor choosing to scale like that? What's it called? Bilinear. No options for bilinear. Blend, multi-sample. What is this guy doing? Where is bilinear scaling? Can I change it to... Actually, no, yeah, it's scaled by the compositor, isn't it? Excuse me. All right. I want to go even lower res. All right. Nah. 640 by 480? Nah. Shift right 1. XD. 320 by 240. We're going old school. Holy. Oh my god. Vulcan. Alright. That might be a little bit aggressive. I can see the points. The overlay is in the way. Okay, so I've solved my problem in a way that means I don't have to friggin' work super hard. Okay, so primitive state. I need to rebuild this pipeline. Over and over again. Unless I make copies. So does this thing have clone? Yay. Okay, so if I go like, oh, you're the pipeline. Debug model pipeline is like that. And I go like, create render pipeline. Bop. Create real label. Okay, let's mutt. I need to mutt and then clone. You're in Canada, right? Yes. So no mutt. Debug model pipeline faces. Face. Okay. Debug model pipeline. Face. Let mutt debug model pipeline edge equals debug model pipeline face clone, and then we go all the way home. Vert. Debug. Goddamn. Underscore face. Yeah. Pipelines. Debug. Underscore face. Face. Oh, that was somewhat convenient. colon WGPU render pipeline. Okay. Oh. 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 Right. Okay, so this thing, I actually can mutt this. Okay. 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 So X back let boom boom boom, not boom actually. I kind of messed it up. Oops. Like that, and then no clone, only own. Okay, so we go like this dot primitive state dot topology is equal to WGPU primitive topology, that one. Point list bow. Okay. Okay. Okay, so let's give them labels. Give me that string. Give me it. Okay. So we go like, hey man, I heard you like, yeah. Okay, debug something dot something label equals to ooh, and then copy this. Triangle list, I believe. I'll just call it like this, I guess. Face, edge, vert. Edge, vert. Okay. Haha, yes. Yeah. Wow. Okay. Debug model, debug models, debug meshes, mesh. Is a debug graphics mesh. Am I gonna have to generate like faces and stuff? I think I need to make a new branch. Debug MD. Graphics MD. Drop resolution for thick lines. Bow. Bah. Debug face. Yeah. Oh. So I need more stuff. I need. So I need to run the pipeline for the model. No, I need to run the algorithm for the model. How is it generated? Debug physics models visually. Indices, debug graphics mesh. Jeez. Be right back. Debug meshes. So I need to like look at this, figure out what the hell is going on, and then deal with it. God, I hate it when these headphones fall. Silence. Oh, I'm looking at code. Okay, so for each poly, it's like making a physics groups. Polygon groups. So the crazy thing about this is that all of the vertex information should already be there. So all I need to do is like invent a list of indices, vertex indices, to be like, yeah, draw a triangle formed of vertex 1, 5, and 3. And I'll go like, or like draw a line formed of vertex 1 and 5. It'll go, or just draw a vertex 1. It'll go a little point. Like we saw the points on screen. And that's what I'm trying to display. So I just need to like translate from create fev pipelines. Mesh.indices.count. Okay, this is goated. Okay, this is goated. Okay, if we go to this definition, nor. We're gonna go like faces indices. What? Is this owned? Is this owned? Ish. Okay. I think this is okay. I think I can do it exactly like I'm thinking. Okay, so watch this. So I can go like, faces. Yeah, woo, where are the faces? Vec. Boom! And then I can go, edges. Boom! Verts. Vertex. Verts. That's kind of like really obvious. There's literally only one, and it's like implied by the mesh which one it is. Because I think you can literally upload them in order, right? You just go like vertices, and then that's it. Uh, unique vertices iter map vertex. Duh. Um. How does the get the Okay, we're gonna need to look at physics. Gamesh. Physics. Gamesh. We're gonna need to look at algorithm. Not that. Not that. Okay, verts, unique pause, iter, copied, map, vert, collect. Okay, that's a smart man. Boom! Okay, so the vertex IDs are one-to-one with the physical vertex IDs are one-to-one with the graphical vertex IDs. Wait. Unique pause. Yeah, it's one-to-one. Okay, so I actually don't need to list the vertex indices separately because I can Is that true? Is that true? I think you might have to. You might have to make like a GPU side buffer. So what are we looking at? What is this? Mesh indices buff slice. Yeah. There's something else. You can do like something else. You can do like yeah. Okay, what's this? Base vertex. Ha 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 ha. I can use this. Why is this I-32? What the hell? Oh my god! Does it wrap around the back? Okay, that's kind of okay. Okay, so I can skip uploading vertex indices lists of length 1 for each vertex. I can skip uploading that. Because this function has enough arguments. So I can just say like, oh yeah, draw one of them. Oh yeah, start at number. I can just do this. I do need the original. God damn. I want to do this once. What a song. So I only need to run this once. I only need to check the vertices length once. Okay, so it actually doesn't matter. I'm just gonna like write a stupid function and get a stupid result. Let stupid function equals to this, semicolon. And we go like this. We go like, oh, yeah, oh, indices. And that's the function. Yep. 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 Type annotations needed. Yeah. Okay, what if I call the function? So indices is stupid function. How about I go like this? I think that's kind of nicer. How many vertices are there? That's len. I think I can do this, and that's an into iterator. Range usize into iter map vertex ID. Oh. Yeah, I'm making it generic here. God dang it. Impl into iterator item U32. Is that allowed? Are you allowed to do that? Impl tray is not allowed in closure parameters. I'm working too hard on this. All right. Okay. Fin. If I fin, does it go bad? Fin indices 32 device WGPU device. Yeah. And then indices and then return nothing. And then tab, bab. Oh, no, I actually do need to return indices. Indices. 23. Right. 16. Can I say, like, yeah, man. Yeah, dude. It's not the same. Whoa. So this is a function pointer, which like you don't want to do. And that's why I was like hesitant about this. Takes 2 arguments. Yeah, you're right. Device. Item equals U32. That's very true. As U32. Okay, what do you want? Oh, right. Yeah, no such. Wait. Oh, yeah. Verts. Whoa. Crazy. That's crazy. So now I have a function pointer, and like it's gonna be slow. I don't care. I need to debug it. Okay, debug it. I'll call it slow function. Slow function pointer. Okay. Okay. So then. Oh, is it not gonna work? We'll see. We'll see. That's interesting that this coerced like that. What about the other ones? So what I need to do is generate the correct polygons. Physics groups. What do you mean? Physics groups, mesh topologies, physics group, polygon group, polygon group, vertices. This is a face. That's a face. It's a face. Is this? Do I have any hash tables in here? I do. Oh, but it's like Bing from Bong. Am I iterating it? I'm not iterating it. Shark attack. Okay, I don't see any. Any of these have a hash map? It's just it's not itered. It's just a map. Hash set faces. This is mega tough because I'm like generating all this topology on the fly, linking it back to vertex IDs. Jesus. I think Are you trying to active visualization? Yeah. It sucks. It sucks. I don't know if this is gonna work. It doesn't matter though. I can figure it out. I can figure it out. So, problem. I need to display Edge ID. Edge ID. Oh, I know Edge ID. And then it's like, Edge can easily be turned into a vertex list. But you can't actually do that. I think. It has to be already uploaded. So faces, I could like. They're 1-to-1. The face IDs are 1-to-1 with the polygon group stupid thing. This thing. So this enumerated is the face ID. So drawing faces, not tricky. But then drawing an edge, which the hell edge is which the hell one? So I have an edge ID. I guess I could, but I have to generate it ahead of time. Can I just like upload things to the GPU in the middle? That would be complicated. I don't want to do that. The problem is I don't know what the edge IDs are in the graphics pipeline. I have no idea. So if at draw time, if it's like, oh yeah, draw edge 5, I have no idea what that means. Because the topology only it's generated right here, and it only exists in the physics mesh. Gabagoos. Okay, new plan. What if I make a make a physics mesh right here. Right here. And hope it's deterministic. And then I drop it instantly. I think that might work. I have to add the physics as a dependency, which is XD, but this is test. Element of P. XD. Okay, so we do physics, straight physics model. Hello? Physics mesh from mesh. I think it's try from. Great. Arg. Debug meshes. God, do I need a freaking like hash map? Collect. Alright, filter map. Mesh. Try from. Okay, question mark, semicolon, physics, mesh. And then at the end of the scope, we have to do sum. And then collect into a gabagoo map. We need to... What? What? Is that allowed? I think it might be transparent. I forgot about the deduplication. The topology is the same. It should be transparent. I should just be able to go like, oh yeah, draw mesh 15. Instance 5 of mesh 15. And this edge. And that's the same for every instance. Because the topology is the same. It's just like transformed, skewed, and stretched. Okay. What is that? Modules private. Are we being for real? Okay. Okay. So if yeah. Okay. Okay. So now I know the edges. That was basically the problem. It was the edges. And I just like sledgehammer solved it. Okay. Okay. So I need to... if this is... Honestly, I could probably get away with just like giving it an empty edge list. All I really need to know is the edges. So I could just say map. And then no. And then no. And then this. No. No. If let Okay. Physics mesh equals to try mesh. Generate edges. Else, I don't care. Just like make an empty list, probably. And then well, order physics groups iter, polygon group iter, polys face ID submesh faces len. Submesh faces. So that's gonna be groups polys flatten. So, who is this? That's the big guy. Oh. I forgot about submeshes. It doesn't happen, but we know it. We know it. Graphics mesh. No. No. It's actually do like this. Graphics submesh. And then like this. And then like this. Submeshes. So one vertex buffer, list of submeshes. Each submesh has its own indices, its own faces and edges. Why don't we organize these so they're not cringe? Vert edge face edge vert, whatever. Hot diggity damn. Damn. Okay. Wow. So the faces are per submesh. Submesh vert ID. That's also real. But I should be able to use the mesh topology to get the like outer mesh vert ID, right? Right? So look. There's, oh my god, where? Okay, it's up above. Okay, hello, who is this? Mesh topology. Submesh vert ID indexes this list. Yeah, so I can just go like, oh, what's the outer vertex? Oh, what's the number? And then that's the vert, because it's the same thing. And then same for the faces. Oh, what's the face? Oh, oh, wait. So then, face. What? Faces. What? Collect. Faces. What? Faces. Push. Mesh. Face ID or insert with. Oh. So edges only exist in the submesh, but I could potentially have global verts and global faces only. And that's like noise and deduplicated. This is getting complicated. There's no global edges. That's very interesting. Faces are global. Gaga. Gabba ba. Verts. Are you allowed? And then edges. Not real. It's not real. Well, it's kind of real. If there's no physics mesh, we do not care. We do not care. Physics mesh dot submesh excuse me. Yeah, wow, I can actually make a little helping function here. Mesh data equals physics mesh dot you can't get it. Oh wait, mesh topology? No. Okay, it's a mesh. It's a mesh view. Physics mesh. Submesh views. Topology. It's a physics mesh view. And then you can run the you can do it. Complete mesh. It's submesh views. That's what it does. How did I make this good? Len equals 1 complete mesh. Complete mesh. Wow. Iter. Wow. Views. Okay, so now you have the guy. What can you do with this? You can do this type of stuff. I need just like edges. And then like grab the vertex stuff. That's just what I need. I'm just the messenger. So if we have a physics mesh view, do we impl this at all? I think I can. I'm just gonna make a stupid function, and that's the end of it. You can't stop me. Public function. No, it's something. Okay. And it gives. Topology edge. Topology for edge. Oh no, this is iter. Iter, right? Plus iter map edge. Self dot data dot verts edge verts map vec vert, that's right. Okay. Vert ID verts vert ID get as you size. Get. How do you dot zero? Okay. What wouldn't we? No. No. It's this. No. Topology verts dot get. Okay. Edge verts iter. IDs. And that has it. That's what it is. Dot. Iter. Huh? Map. Submesh. I already did that. Submesh view. What is up? Iter. Collect. Fin. It's fin. Iter. Who? Yes. 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 So not quite. Not quite. So we have to iter. What the hell? What the hell? So we have a fin into iterator. So this, I need to call this every time. Slow function pointer on this vert ID iter who what into iterator item into iterator dot map function pointer collect. Oh, device ID into iterator. Oh my god. Okay. No such field. Submeshes. Yeah. No. Debug graphics submesh. Right. So debug graphics submesh. Edges? How do you do it? What do you say? Oh my god! Okay. Wow. Wow, wow, wow. Okay. 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 Okay, so then what about this? So now it's like, expected rate 2. Yeah, not so great. Not so great. So now we've like, I expected this to be a problem. I said into iterator. Can I say that again? Can I say like no 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 no. If I say like, oh, you're actually a that goes from to is that gonna work? Ah, okay. Infiltrate's not on function parameter. That makes sense. Makes sense. So I can't like T. I just like the it's you. Yeah, I guess that makes sense. I don't want to run this if statement 100 times, but like it doesn't matter. Okay, this has now become a challenge. I'm gonna step up. How do I do this? I left for like 10 minutes. What did I come back to? Um, uh, don't worry about it. I wrote uh some like bowels of graphical mesh equivalent topology generation for physics meshes. It's like creating a physics mesh. During graphics, I actually added it to the dependencies just so that it can get the correct edge IDs, so that it can then display the edge at runtime. It's not good, but I just need to see it. I just need to see it. So I'm trying not to run this if statement every single time. So I was trying to make a function pointer to a function with a trait bound, but that doesn't actually make sense, unfortunately. So the question becomes, should I macro? I think I'll just macro and like whatever. And like if the compiler can like see through it and unwind it, then like great. Otherwise, sorry. I wonder if it's gonna want like types. That would freaking suck. Okay, so device is everywhere. Panic is everywhere. Semicolon. Oh, macro. So we want to go like macro rules. Jesus. And we do indices. Oh, you don't have to. Okay. Oof. So we just do indices and indices, and that's it. And this goes down here, and this gets no semicolon, and we're done. Oh, expr, I guess. Okay, so instead of slow function pointer, we do indices. Yeah, let's go. Wait, ID. Wait, no, that's it. Gabagoo. Okay, so this isn't ID. This is like, edge reverts. Okay, and then this guy is not real. We just go like yaman. And we actually don't even need this, I think. Okay, so it's just gonna run the if statement like 300 times, but like nobody cares, so it doesn't matter. Okay, so then now we need to generate the faces. We need to generate the faces. Group. So this is the mesh ID, and this is crikey. I think actually I need both in the physics mesh. submesh views. But I don't need the submesh views there. I can just directly grab the top level faces. And have, and then triangulate them directly. Directly. And then we do like this. Faces. Back. No. It just doesn't matter. We're not going to try to draw a non-physics mesh ever, because the ray trace is sweeping through physics meshes. I just realized that I may want to have a graphical BVH as well. And should that be separate? Just a question for later. That seems, yeah. That's probably why Roblox has the like can query stuff. Okay. So we have submeshes and we have faces. Aha. And then this is submeshes. And this is faces. We'll start with this. Okay. Down. Oh, it's not that song. So directly faces, actually. Face normal dot. God damn it. No. Isn't it fine? We can go by that. Oh, I guess we can do the mesh topology edges. Gah. Oh. No. It's gonna be easier to do submesh faces, I think. So I'm gonna change this back. And we'll just go submeshes. And I'll generate both here. Yeah, so it's gonna be easier to go like this. So the verts can stay there. The faces, like, I could probably do overall, but like, no point. Okay, so we can also have a shrimpler function for the other one. Probably widowy exactly the same. Edge, 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 face. And then like just go make that function. And that's it. So go over here. I have a function. I have another function. Edge, face. Wow, face topology is real. Okay. That's not real. That's right. That's right. Oh crap. Crap. What? Wait. Okay, what is in here? Do we care? Oh, it got through. Sometimes they get through, sometimes they don't. It's really irritating that people fall for that and get their accounts stolen. So I have to deal with it as well. The like 0.1% affecting the 99.9%. How does this work? Face refs. Oh, I'm gonna have to dig down. Directed edge ID. Ugh. Okay. So edges. Edge ID. I can just do this, right? How it's okay. I'm gonna save this as a snack for later, and then we'll do self dot edge. Wait, edge verts editor. Wait. That's we kind of actually, but kind of not. Okay. Edge verts. Do I want to do that? It's as ref submesh vert ID. I feel like the lifetime is not going to work out. Okay, I can just go to this implementation. Topology, like that. Okay, so dot verts. So now we have the verts, edge ID. We need undirected. And then verts. We need the one with the parity. Dot parity as use size. I believe that's the play. And now we have submesh vert ID. Let's just split this into 2 lines here. It's a little bit unwieldy, a little bit wobbly, you know. Let vert ID equals, and then we go like this. And surely the lifetimes will work out and everything's great. Great. Yeah, I'm not proud of that. Collect, semicolon. Oh, okay. Come on, man. There's no semicolon. You don't need it. You don't need it. Okay? You don't need it. Is it like the freaking... Do you want that to ruin it? Like... What? Literally does not matter. Does not matter. U32, impl iterator, into iterator, literally does not matter. I think this is a macro. Expected semicolon found burp. Oh, let. Get out of here. Jesus. Okay. So that actually... Oh... I actually need to triangulate this. Okay, this is gonna be a mess. I can actually... No. It doesn't matter. No. Damn, Rust is so crazy. Phew. Jeez. Okay. 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 Whatever. Okay. Okay, now we have generate topological indices. Not the best comment message ever, but geez, that was involved. Why did I just unstage? Okay, we're running the if statement 700 times, but like, it's just for testing. It doesn't matter that it's slow to load. I can wait 10 minutes if I need to. It will be like less than a second, but it just doesn't matter. It doesn't matter. Iterators are nuts. Okay. 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 Graphics MD. Welcome to Graphics MD. Okay. So now we actually want to look at the FEV. So I need to find the old code here. This one. None. Replay. What? What? Whoa. It's here. Okay. So it makes array. It finds the model. Then I have to run the MD. Maybe here? Maybe? So it runs regardless if the was if let some model ID equals to model ID. Minimum difference. Minimum create. Minimum. What? Session! We're in session. Oh. Oh. Is that allowed? Function, closest fev not inside. Self. Model ID. Model ID. Option. Fev. He. 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 Who? 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 Where did it go? Mesh view. I think F it. Data model mesh. Convex mesh ID. Ma. 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 Convex mesh ID. Model ID. Reference. Okay. 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 And we accept a reference. T T T T T T T T T T L L L L L L L L L L eh oh eh eh huh 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 oh huh huh uh uh how do so I need to like grab the from here. the this is a excuse me. No, okay, okay. Does it? Okay. Well, uh, 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 uh. I have the fev. I have the fev. Match the fev. Grab the mesh. 0. Match fev. We fev. Model physics. Oh. Isn't that me? Oh. What? Oh, this is. Oh. Okay, so we can do that. It's actually not shorter. Okay. Convex mesh is more private. Unlucky. So we have a Minkowski face. Oh. Oh. Match. Mnatch. No. 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 Do. So this is mesh 0. Look at it. Mesh 0, mesh 1. Mesh 0, mesh 1. Mesh 0, mesh 1. Mesh 0, mesh 1. And then we do not care. We do not care. We do not care. Underscore. That's how much I don't care. Dot, dot. That's how much I don't care. Underscore, 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 underscore. Oh, so this is actually different. I feel like I should generate the vertices per submesh, because it's annoying to not. So I think I'm going to do that. Okay, watch and learn. So we go fev. Oh, fev, fev, fev. Fev. Face. Or whatever it is. This is a vert. This is an edge. That's a face. La 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 la. And then that one, vert, edge, vert, Okay, so it even handles Minkowski edge. That's crazy. So if you're like sitting like this, it'll be like, oh, the edge is close. The edge, see? And it'll just know. It'll just know. Unused qualification. Oh, do like this? Bubba is more private. Convex mesh. Okay, I don't care. Public. Okay, just relax. And then something. Okay. So now this is a reference? Ow, 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 ow. I don't want the lifetime. Yeah, I think it's more convenient to just destroy the lifetime. Physics model ID. So I needed to do that. So this one's okay. This one's okay. We can just do this. We don't care. I don't care. I don't care. I don't care. I don't care. And then here, who did this? We like this. It's probably gonna kill me. Yeah, okay. Oh man, it's just like whatever. Okay, just go. Okay. Now what? No. Uh, uh, so, eh, eh, uh. I need Fev. I can just keep it like keep it real. Oh, option. Never mind. And like that, and then static. I should be able to say static. No, physics. Static. Oh, and then this function, I think I can, where is it? Say static here as well. Static. And then, do you like that? Bouquet. So then we can say none. Okay. So now, why is this here? Oh. We don't care. We don't care. We don't care. There's duh. So we can say convex model ID. Then we can say model ID equals to convex model ID dot into model yeah bleh 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 bleh. Okay, I got it. Got it. Okay. Map. It's map. No, no, I have no idea. Um, God damn it. Okay, so I can't grab it. Model ID. That. Yeah, yeah. I think I need both. Uh, yeah. All right, we don't care. We don't care. We do not care. Where did it go? Graphics. G g g g g g g g g. Model ID. Model ID. Sheesh. And then it's so close. So close. Uh, is option. It's option. Um, it option. I'm thinking about data modeling at this time. Option like that. So we only care if it's real. We want a mutt. I want a mutt. We want a mutt. Yeah, I'm gonna say pub struct hit. It doesn't matter. It literally does not matter. So we go option. It kind of a little bit like this. And then Feb is like that. This is like that. And this is like that. And then now in frame state, I want hit instead of it. And then in here, oh, that's a little bit troubling. Hi. I'm working hard. Not hardly working. What is that? Behind a shared reference. Oh. I can clone copy. Crap, I can't clone copy. Why is Fev? Get frame state. Where? That's right here. Get frame state. Hit frame state. Who put this? Frame state. Frame state. Frame state. Frame state. Self. Okay, frame state can have a lifetime. Option, reference, debug model, option, reference, frame state. It should be able to figure it out. Okay, it wants it. Okay. As ref. And then I need to set it to none if this is none, and I need to set it to some if this is some. Okay, I think we just match. Match convex mesh ID. And then not equal. Okay. We don't care. 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 We do not care. We do not care. We do not care. No, 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 no. Okay. Some convex mesh ID. I can actually inline that. Grab it, it's here, grab it, hit, grab it, boom, 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 boom. It didn't work. That's true. You're so true. True. Some hit convex mesh ID, hit physics model ID. Why is it trolling? Missing structure field the last ray hit. And then this is not real. So if there is a mesh, find the closest point. If there is none mesh, then there is none mesh. And just, it's none. Yeah. What do you want? What do you want? Unused. Okay, so now something has happened. Hello. Hit. 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 Hmm? Public. Hit. There literally is, my good guy. Literally there is, my good guy. Type definition, convex mesh ID. There it is. Graphics, convex mesh, model ID, mesh. Oh, I got it like totally wrong. Okay. Okay, so now there's a hit. We actually don't care about this yet. We're gonna go to if let's we can. It's okay. It's okay. It's okay. What's this? It's okay. Okay. It's okay. Closest fev equals hit dot closest fev. It's gonna complain to me about the on the but that's okay. So we only care if it does like that. It's a fev. And then if there's a and the then we go and then we go So no. Do we have to do this in order? I don't know. Let's see. Match fev. Fill match arms. Holy moly. And then we do hello. Face submesh face ID. So we have the hit dot buff where what do you mean what buff what why did it say that? Don't say that. Did I name it something else? Indices. Oh. Why does that say buff? Indices.buff. Okay. Okay. Oh. Faces. Face. Dot buff. Oh my god. So here is indices equals to reference to boop boop, and then we go indices.buff.slice, indices.format, and then we go indices.count, and then this needs to be a reference. Okay, I do believe we can draw faces. Next is edges. Okay, so edge, vert. So we go like this. Debug edge dot edges dot edge get the edge, and that's it. And then for the vert, it's a little bit different. So vert. So we don't need to go like this. All we need to do is go like mesh dot verts. It's a big fat global Oh. Okay, I can actually add it here. Mesh. So mesh. Mesh. So I can. I can add the mapping. I guess that's per boop right here. So I need verts, and then U32, or should I call it a physics mesh? No, physics vert. I don't know. Vert ID. Mesh vert ID. Physics model mesh vert ID. Type. Yeah. And then now you map because this one it knows all of them, and then this one it knows which one means which one, and then that's how you do it. Vert. It should be just like clone, right? Submesh view dot verts, like clone it. Just clone it. Data. No. Topology. Verts pub clone. Done. Topology. It's private. Physics mesh view. Help. Physics mesh view. Topology. pub. You know what? Well, why don't I just make a thing? Pub fun clone vert map, whatever. Self. Then I don't need to make it like pub and stuff. So vec physics vert id measurement. It's this one, and then self.topology.verts clone. Yeah. Actually, why don't I do it like this? Cause then I can clone it outside. Verts. Wait. Yeah. Okay. Verts. 2 owned. And we're cooking. Big time cooking. Just always cooking. You know how we cook. All right. So now we got the verts. And that's the indices. And that's the and then it's so close. Is this a range? God damn. Okay, I think I'm gonna use this one then, because otherwise it's stupid. So let vert id equals to mesh dot 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 get yes get and then this is 0 to 1 starting at there. Done. That. Okay, so I have just splorch coded this into existence. So I don't think I actually need this. Revert. Where can I top? Did I write? I guess not. Right. I just stopped myself right before. Physics mesh view. Yeah. Okay, I didn't make it pub. Q. Okay. For real. Okay. Damn. Lifetime parameter. Render session frame rate. Worker 6. Can I'm just gonna clone. Just clone it. Okay? Just don't. don't, 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 don't. Eh? Wait, it has it. Eh? 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 Uh. Clone. Really? Clone. Okay. Yeah. Okay, do not the lifetime. Whoa. Okay. I make no guarantees about what's about to happen. I believe we're going to see lines and faces and vertices. But I don't know. We could also see big crash. Oh, would you look at that? Huh, 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 huh. That looks like indexing problems. That looks hard. Indexing problems. Mm. Ooh, ooh. Would do you see the red line? That looks correct. Okay, so the faces are the big wrong. Ooh. I don't see the point. Oh. Do you see a point? Do you see a point anywhere? Is it right there? It is right there. There's a red spot right there. It's so hard to see. Um, sure, 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 sure. That's the closest point. Right. It's part of a Minkowski face. So probably there's a line on the hitbox, and then it's a point on that object, which like that's like right. So why is this? Oh, is there indexing problems everywhere? Oh yeah, no, there's definitely indexing problems everywhere. Okay, so somewhere somehow in the spaghetti that I just wrote, I made a mistake. Yeah. How many lines of code was that? 160. Ugh. Oh, interesting. The triangulate had the same tabs. That's very funny. So I do believe this is wrong somehow. Mm, 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 mm. Uh, uh. uh, 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 uh. Submesh directed edge topology, submesh vert ID verts. That just looks right. We're grabbing the big guy. Verts, mesh vert. That just looks right. Ugh. So, as far as I can tell, these are correct. Whoa, whoa, whoa. Whoa, 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 whoa. Oh, whoa, whoa, whoa. Okay, okay, yeah. No, that makes sense. This. So this indexes into this list. So it doesn't matter how long the indices list is. It only matters how long the vertex list is. Just saying. Where did I go wrong? All my stuff, I tried really hard to make it like correct. Let's see. What does this say? Submesh ID. Yeah, that looks good. Submeshes. How did I mess it up? Oh no. Is it random? Are is the generated mesh topology random? Physics groups iter hash map entry. I don't think I'm iterating over hash maps. Like, this is definitely not hash maps. Freaking trait. I need to get rid of this trait. I'll do it later. Well, fantastic work today, even though it's like not working. It does it. This looks deterministic to me. Edges insert hash set. So it's like using hash maps, but it's never iterating over hash maps. Collect. Oh. Okay, that's it. Okay. Vec. Does this? I do. I must use these somewhere. Okay. Wait. No, I don't use these, right? Vert refs? No, I don't actually use these. So if I did use them, it would. It's not. It's not an index list either. It's an unordered list. So these are random, but it's an unordered list. Interesting. Hmm. Hmm. Uh, what if I make this Meshford ID? So instead of get, we just leave it, and then now it's Meshford ID, and then over here, in the indices, we have to say get. U size. Oh, I see this. I see. Yeah. Okay. So vert. What? Oh, verts physics vert private. It's private. Wait, no, it's an ID, isn't it? It's an ID. I can do it. Here we go. Think. Yep. Dot map new. Like this. Is it private? What's up? Oh. Holy. Okay. So it is type safe. Ugh. enough. Zero. That's okay, right? Because that's like how it is. It's only used for vertices, and the vertices seem to be working fine. Wait, can I flat map this? Dude, I can totally flat map this. Indices extend ABC. So I pop a few bops off the iterator, make a new iterator that iterates the iterator. Wait a minute. So this... So I only have AB if I do this. How do I make it the same return type regardless? All right, AI. I can't think of how to do it. My brain is done. Hello? Rewrite this to avoid allocating an intermediate vec for indices. Just triangulate using a flat map. Go. Go. AI go. Think. Don't think. Just go. Face ID verts iter. Yeah. Ooh. Ooh. Damn. Yeah. Actually, can I question mark this? No. Cause okay, the big problem here is you can't like return an empty iterator. You must map it, and then you must pull these items to create it. That's one type. All right. Well, presumably it exists. Whatever. It doesn't matter. It doesn't matter. I'm gonna stop thinking about it. Okay. I don't know what this would change. What the tarnation? Oh my god, the pixels are so huge. I need, wait. Is that? What about backface culling? So that looks correct, don't it? Yeah, look at that. So we got the front face, the side face. Let's go. And then if we go down here, it's the edge. Whoa. The top edge. Wow. Wow. We go over here. Uh-oh. Oh, no, it is there. You can see the red dot right there. So is that bug still crawling around? If we go over top of the face, is it? Oh, why am I standing on something? Oh, jeez. There is bugs, and I don't know. Face, edge, wrong. So I like the fact that it's not crashing. That's pretty neat. So what it's supposed to do is it's supposed to show the closest point to me. So in this case, there's a red line here because the red line on that shape contains the closest point. And if I move above it, it should show the whole face, but it doesn't because it's like wrong. But I don't know. Oh, interesting. It doesn't work like that. So yeah, it's like I think the indices are wrong in some way, and I'm not sure how it is wrong. Stealing this visualization idea. Oh my god, it was so much work. Oh, hi, SoCam. Yeah, feel free to steal the visualization idea. You're gonna have to do all the work though. Ideas are worthless. Give them away for free. Yeah. Look at this. Look at this code. Oh, where's the code? Oh. There it is. Nope, that's not it. This is still cool. Okay, so I have my physics data. So that includes the meshes and models in the game and my hitbox. And what I'm doing here is I'm finding the closest point on some sort of given mesh to the character. So I make the Minkowski sum of the mesh and the hitbox, and then I find the closest face, edge, or vertex. And now this is a Minkowski fev. So I match out the Minkowski fev, and Minkowski faces can be like this. A Minkowski face can be like a face and a vert. It can be like an edge and an edge, or it can be like a vert and a face. But I don't care about mesh 1. All I care about is mesh 0. So I just take whatever the vertex is on mesh 0 and return that as a vert, or the edge, return that as an edge, or the face, return that as a face. I just throw out the value from mesh 1. And then same for an edge. Edge can be like edge vert or vert edge, but I only care about mesh 0. So I'm just saying what the result is on only mesh 0, which is really neat. So I find the closest point between two meshes and then give the result on mesh 0 out of here. That's very cool code, but that's not the code I wanted to show. Where is the graphics? Graphics, right here. God. So now that I have this fev for mesh 0, I'm sort of extracting it here. It can possibly not exist. If you're looking at nothing, or if there is no closest fev because you're inside the mesh, it can possibly not exist. So if it does exist, we want to draw it. So this is WGPU bind groups. I checked out your repo. You might as well have encrypted it. Style is confusing. I tend to not use spaces. It's are you familiar with Rust? Rust is basically unreadable until you learn Rust. Yeah, I'm just doing it for me, and I don't really have any formal like style training or anything. I'm just completely self-taught, so yeah. Okay, so we have a closest fev on mesh 0. If it's a face, well, we need to draw the face. So I've already prepared a pipeline to debug faces, a pipeline to debug edges, and a pipeline to debug verts. And there's differences between those. So these are the vertex indices for that face. So submeshes, submesh ID, faces, face ID. So each mesh can contain, so this could be like a overall mesh, and it can contain multiple submeshes that are convex. And the overall shape doesn't have to be anything as long as the submeshes are convex. And the idea behind that is that, like, imagine you're climbing up a ladder, and then the ladder is like curved. In my game, you lose all your speed when you touch a ladder. So you jump on a ladder, poof, you stick to it. Then you start climbing it, poof. If you still lost your speed when you changed to a different submesh of the same object, then you would lose all your speed again. But since it's a submesh of the same object, you don't lose your speed because it recognizes, this is the same part of the ladder. So you can just go, woo. So that's why there's submeshes. Remembering your context to navigate it. With spaces, you can chunk the information into blocks. But think about all the bytes saved. When you're downloading it from Git, it was 10% less size. Think about all the bytes saved. Efficient. yeah, so there's face, edge, and vert. Let's look at the pipelines. Pipelines. So we have this debug model pipeline. It describes a WGPU pipeline, which is kind of like a Vulkan pipeline. And like the vertex are laid out in a certain way, blah, blah, blah. It has a shader. So the important part is the primitive state here, which has a primitive topology component. So I set the label to debugging the faces. I set the primitive topology to triangle list, and I create a new render pipeline for faces. And then I set the label to edges, set the topology to line list, and then create a new pipeline for edges. Vert, point list, create a new pipeline for vertices. So it's very cool. Format and save. My enemy. I hate that so much. I instantly disabled it. Not just because of the spaces, but because it like messes with my code instead of just saving it. Why did you create a different pipeline for each? Well, edges have to render lines, faces have to render polygons, and vertices have to render points. Is this gonna... There is actually a red dot right there. I promise. On this vertex. This is the closest point on this box to me. So Vulkan is very not dynamic. So I have to pre-create the like my rendering plan ahead of time and be like, I'm gonna render like this, right? It's very not dynamic. Can you render points with more than 1 pixel? Not that I know of. That's why I turn the resolution down, because this is a 4K monitor. And I could not see the pixel, but now I can just barely see it. I wish I could disable bilinear filtering on my compositor. I'll look into it. Just give me like, I'm just gonna look for a minute or two. J. Bilinear. Okay, let's try it here. Bilinear. No results. Okay, cool. It can't do it. Maybe you could draw a tiny quad. Yes, I could do that, but that would involve creating a new shader and like a vertex thing, and I just didn't want to bother. Because like it's just for testing. I just need to see what's going on. So I just lowered the resolution, and that made the edges bigger. So yes, but ouch. Okay, so I'm having problems, as you may be able to tell, where like it's drawing the wrong stuff sometimes. Like, that doesn't make any sense. Like, look at that. I think this is a bad triangulation, as well as being wrong. So I think I'm having vertex index issues. So each mesh has a list of vertices, right? So like, for for the corners, it's like 0, 1, 2, 3, 4, 5, 6, 7. The order isn't important. Cam is over it. I guess move it on the left. So there's 8 vertices on a cube. And indexed rendering uses the vertex indices. So you upload the vertices to the GPU. You're like, this one has position 1, -1, 1, -1, 1, 1, whatever. And you upload those 8 positions, and that's your vertex list. And then you upload vertex indices. So like 6, 3, 1 will be a triangle, and then 1, 5, 6 will be a triangle. So that's 6 numbers, and you upload that to the GPU as your indices list. And now I can draw this face by saying, use these indices and these vertices and draw it. So that is the code. It's the code. That's the code. The code, right? That's the code right here. So we have the vertex buffer. So all of the vertices are the same for faces, edges, and vertices. Drawing. So I set that ahead of time right here. And then the indices are like for the face. So it's like, oh, there's a triangle here and a triangle here. So there's 6 indices for that, to draw that face. And then draw indexed, it says what range of the indices to draw, which I just want to draw all of them. So I just go 0 to the end. And then there's an offset, start at 0, man, come on. And then instanced rendering is very cool, but we only have 1 instance. So this is indexed rendering. And there's also instanced rendering, which I'm also doing. A little bit complicated, but very fast if you implement it. You get a huge performance boost. I think it was like double. No, it was bigger than double. Especially after I optimized the meshes and stuff. I think I went from like 50 FPS to 2000 FPS for this map specifically. With instanced and indexed rendering. Very, very good optimization. So that's why it can be wrong. So that's why I think... Yeah, look at that. Look at that. Look at that. See how the triangle comes down and goes... and then goes like this? It's triangulated a list of 4 corners of a face, but it pointed to the wrong vertex. Why? Instancing was likely the biggest boost. I think you're right. Am I stupid? Hold on. Yes. Right? No. Okay, so the vert list looks correct. Every time I've spotted the vert, it's been correct. So like If I go up here, is it there? I don't actually see it. I don't see it. I don't see it. Oh. Oh, I see it. It's over there. It's actually wrong. What? I can see the little red dot over there in the corner. Okay. So all of them are wrong. Where am I indexing wrong? Submesh ID, model ID into? It's not the wrong model ID because it would just be like something somewhere else. Linear algebra. This is just like indexing. My indexing is wrong somewhere. I don't think it's here. I don't think it's here. Physics mesh view verts. Topology verts. Because like it's always going to the top level vert ID, which is type safe. Edge topology edge verts. Wait, edge verts map. No, yeah, no, that makes sense. That makes sense. Verts, it's grabbing the top level. Verts. It's always using the topology map. Physics mesh topology. And like if we look at this type, mapping of local IDs to physics mesh data IDs. So basically, submesh vert ID indexes this list. Submesh face ID indexes this list. And then face ID indexes this list. Or mesh face ID. So this is the like overall faces and verts. And it's the same order. It's the same order. It's the same order. Verts. 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 Unique pause iter copied map vert collect. That's not a hash map. We're not iterating over a hash map, which is a random order, which is directly one-to-one. Invisible on stream. Yeah, nearly invisible to me as well. Arg. Why? I don't understand. How is it wrong? Roots. Okay, what about in here? Convex mesh ID. Submesh vert ID. We could actually say that this is physics model view. Physics mesh view. Oh, apparently this is in scope, so whatever. Doesn't matter. Like the model IDs and stuff, if they were wrong, I wouldn't be looking, it wouldn't highlight what I'm looking at. So it's not the model ID. And like, if the position was wrong, it wouldn't be like misindexed. How are the indices wrong? It's either here or here. There's 3 places. Vertices, debug graphics vertex. We actually don't need the normals whatsoever. Unique. Whoa, 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 hey, 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 whoa, 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 whoa. I think this is wrong. Where was I? Oh God, where did I, graphics. Look at this, unique vertices. Where's the goddamn unique pause? Oh, okay. So I am like double indexing. It's kind of stupid. It's kind of stupid. Okay, I got confused. Okay. So, okay. So, yeah. So, okay. Physics goes by pause. Pause. Where am I? Oh my God. Pause. Vert ID is pause. I literally just don't need it. So why don't I go here and remove it? Get out of here. I have to make sure to update it everywhere. Like here, especially. Nope. Pause. Ooh. Yeah. Work. Pause. Can I copy? Copy. Pause. Right? F. Oh, it's F. God damn it. Okay. Pause. Okay, so I don't need to do this, right? Into. Would that work? I don't know. Pause into. I don't know if I. Yeah, no, I don't have it for references. Okay, whatever. Just copy it. Oh. I have to map into? How cringe. Does that work? Do you like that? You hate it. Array. To array. Is that real? Okay. What was the old stuff? To array. Okay. Okay, I think that was the bug. The bug. Now it'll work. Definitely, for sure, definitely it'll work for sure. What about... Okay. Surely. Oh, pointer, float 3x3 into... okay, I think I need to change the shader, and that's why I didn't do it. Think. It's right here. Location, new, normal, new. VS debug, new. It just doesn't care. I could just remove this whole thing. Model instance, whatever. Okay. The bug. Okay, surely it works. Ah, crap. Build it again. Go Naga. Shader compiler. Yay. That's wrong. Not really, actually. Ooh. Yeah. It's on the vertex. Whoa. Look at him go, man. Oh, it's so right. It's so correct. Oh, my God. It's so good. Oh, my God. Trey's code is so good. Oh, my God. It's just always right. There's no bugs. Oh, my God. Okay, so I am not looking for bugs in this code. I am looking for bugs in my code. Holy. Jeez. Okay, so what are we looking at? What are we looking at right now? Trey carrying strafe client. I mean, he carried B-hop as well. What are we looking at right now? So this is which part of the mesh contains the closest point to me. So in this case, this red face contains the closest point. So there's two constituents involved here. There's me and there's the mesh. So wherever I am, it's finding the closest point on the surface of the mesh to me. And then it's highlighting that. So if I'm like over here, then like, oh, this edge is the closest point. And if I'm like over here, and that's like, oh, this vertex is the closest point, which is hard to see. That's what's going on. And it looks like it's always correct. So you may not be able to see, there's a dot here. I would like to make it bigger, but WGPU doesn't support thick lines. Wow, it's so accurate. Interesting. So that one looks kind of wrong. Oh. Interesting. So it's returning equivalent answers for this one. So right now it's returning at the top. So I extend down by 5 studs. I'm 5 studs tall. And the camera is at 4.5, I think. So it's up an extra 1. So about to like right here is like 5 studs tall. So that edge is correct. This, probably my feet are sticking down, and it's picking a vertex on my feet and this face, and it's saying like, yeah, the closest point is there, which there's a lot of equivalent closest points, so that's okay. This is amazing. I love having an entire ray tracing algorithm for this as well. Oh! Overflow. I think that's my overflow from the algorithm. So I'm hammering this new code super hard, and I wrote it to have narrow, I believe. So I'm narrowing the fixed point numbers. So this is a degree probably 2 fixed point number. Let's see. Yeah, because it's u times v. So we have u is 64-bit, v is 64-bit, u times v 128-bit, and then I'm narrowing it back down to 64-bit and saying, do it. That's shocking. These numbers should not be very large. So, are we dividing anywhere? Let's see. Narrow, narrow, narrow. Direction. Cross product. Okay, this is a 3. I can see this one getting out of hand. Buh. All right, let's run with backtrace enabled and see if we can get that to happen again. I might just need to like oh, there it is. Some details are omitted. How about all of the details are omitted? Can we omit some details? Let me just look at the algorithm here. So if we scroll into the main loop, reduced dir. Okay, it literally just says, okay, direction dot. So I could easily just soup this up. Fart vert. Oh no, I need to use. It has to be here. So I would need to like normalize it if I wanted to narrow it. So wait will we I can drop bits. It's a direction. So it's just like an out outstandingly precise direction, I never normalize. So I can take the log 2 of all the axes, find the largest one. If it's outside the range, shift left, shift down. I don't know. Well, they should be called shift up, shift down. Shift shift down. Shift the bits down. There we go. Unknown, 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 unknown. Right. 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 What if we compile no big one? Damn. Debug build. Yeah. We good. All right. What's the FPS going to be like? Loads a lot slower. Really? Okay. That's very slow. What if it's like hitting an infinite loop or something? It's like different behavior. Here's the bug. Okay, it's not actually running anything. The CPU is like calm. Oh, no, it is. How is it 130% CPU? Did it go on like here? No. Is it like on a screen that I can't see? Let's just try it again. It says starting new run. Is that... Oh, yeah, it's literally not loaded. All right. I'm going to change the op level because, like, Jesus Christ. Oh. Uh. All right, it's one of the. I already know what it is, so it's not a big deal. It's one of the narrows. So I can just make a little function, narrow dir or something like that. Why don't I do that right now? So choose any direction. We'll do narrow dir. Narrow dir. Oh. Is the narrow a trait? I'll call dir 2, whatever. Okay. Dir vector 3 fixed to 64 PV3. So find the biggest axis and count the log 2 basically. Dir dot x dot I want log2 zeros. Okay, what about this? Count? No. Leading zeros, like, can we log? Please, please. Yeah. Let's look at this function. Oh God. Bruh method. Bruh. Okay, bits method. Okay, jeez. Okay, so it's gonna panic if it's negative. All right, that's enough of that. Unsigned abs. buint and ilog2 is still real. We should be able to find it better. Checked ilog2. Great. 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 It's really readable. Checked ilog2. Go to definition. Bits. Checked sub 1. Oh, bits. Is that what we want? What we want? Okay, well, so it can be 0. So why don't I? Nah. Okay, what do you want, Mr. Phone? Is it buzzing at me? A message from my bills. Great. Okay, unchecked. If dir equals vec3 0, return dir. So we just want to like find the biggest one and then shift until the bits are within something. God damn it. Bits minus leading 0. Yeah, sure. Okay, we go with that. So how many bits are filled there. So if there is more than (96 bits), then destroy it. Okay, so if big is bigger than 96, that's not 96, then I'll just write it out in full. 64 plus 32. Then shift them and drift them. So we go dir shift right by big minus 96. Keeping as much precision as we can, else dir. Oh, narrow. Okay. Kind of a Goobert algorithm, but like what are you gonna do? All right, so now we have narrow dir 3, 396. So it's like above the midpoint. So I believe it's 96 plus 32. So this is like the fractional point, right? So we're taking the fractional point and adding, is it 31? Yeah, I think it is actually. $90. Okay. Bits. 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 Okay, so if there's 63 bits, then unsigned abs. I need to take into account the sign bit. Whatever. Okay. Yeah. So we do like this. Narrow dir 2. Except it's a dir 3. Haha, lol. UV. Narrow dir 2. Okay, I'll do the UVs first. Yeah. It's a little bit Scooby Dooby, but oh well. Okay, there's still some left. Oh, there's none left. Okay. So that should go on the master branch. Mindiff branch. Brada. Narrow directions more carefully. Oof. So the problem is there's too many bits, it's too wide, and the numbers are multiplying too much, but we don't actually need that much precision. So I'm just kind of like dropping a bit of precision and then dropping the rest of it. I wonder if it's better to do it in one step. Of course it's better to do it in one step. But like, it's okay. So that's interesting that we never experienced that crash. So let's rebase. And build again. And it shouldn't happen. It's so beautiful. The ray tracing is sometimes wrong, but I don't think that the MinDiff is wrong. The face crawler is definitely wrong. That physics bug I just experienced there, that was Is this a ray tracing failure? Yeah, it might be a ray tracing failure. Min diff appears to be working. So when I drop to the floor, it can't see this object anymore in the ray tracer, which like, okay. I see. So I can see the point right here, and then I go here and you see the face, and now I can see the point right here on the edge. Started run. Nice. Oh, we're getting up to the juice point. Oh my god, I forgot about the juice. All right. So everything up until this point has been child's play. All right, I want to go there. All right. So, will it crash? It's not even slow. This doesn't work. That's correct. That's correct. That's correct. That's correct. Did it stop seeing it? Oh no, it's just it's a point at the bottom. Okay. I can't get it to the, oh, there it is. This is just like correct. Correctamundo. That wasn't the juice. The juice is over here. I think we'll see a lot of vertex. Let's see edge. Oh, this is just exactly what I imagined. I can't see anything. Oh, is it right there? Yeah, I think it was right there. Wow. Okay. It just looks like everything I've seen looks reasonable. It's just reasonable. So we can see that it can't change it. It can't make up its mind here. But that's okay that it can't make up its mind. Because there are multiple correct answers for, so like if they were like this, where they're like randomly rotated, then there's only one correct answer. But if they're flush like this, then you can make a Minkowski face by doing face vert like this, but they're flush, remember, or like this. These are both equivalent to the same definition. So it just picks different things, and it should be fine in the face crawler. It shouldn't like break, but it does break. Yeah, so I don't know why you fall through, but it is very clearly not the fault of the minimum difference. The minimum difference is seemingly perfect. So that is very nice to verify. I'm pleased with that. Ooh, lag. I saw it. I saw it. That was lag. It stopped happening? Was it like the printing? Did the printing cause lag? Oh, oh, I didn't even. Wow. Oh, this is so good. You can see the vertex right here. Sometimes the ray tracer doesn't find this stuff. Okay, how about these guys? There it is. There's the edge. Yeah, highlight the face. How far down can I get? Pretty good. Yeah. It just works. Is there any more complicated meshes that actually have physics? I have yet to see it incorrect. It's a physics bug. No, there's not really more complicated meshes. Let's run. Whoa. What is that? Okay, it's probably seeing the start zone here. Yeah, the ray trace is not perfect. All right, these are boring shapes. This entire map is boring shapes. I'm satisfied. I want to like send a clip to Trey and be like, whoa, whoa. I did a shocking amount of work today. When I woke up, I had no plan whatsoever. I was like, I'm gonna see what to do. And then, yeah. There was a lot of trance-like implementation details here where I just like, there's not really a big point in explaining it because it's just a debug system. I mean, I guess that's not true. It can still be interesting, but like, I just wanted to get it done so I could see for sure if the algorithm is correct. And it is. Fantastic. I think I'm gonna stop the stream and then continue working on like rbx-dom later after I have a break. Off stream. Actually, hold on. You gotta see this. This is cool. Let's go to it. Get rbx-dom. Oh, I actually have to test on my server. If I run the... I don't know, what did I just type? That's right. All right, I'm gonna run the benchmarks, and you can see it. So let's look at the diff here. Okay, so the rbx-dom is a decoder that reads Roblox files. The Roblox file format has these chunks of data, and this decoder is kind of slow, and I've been trying to speed it up for a long time. I found a way to speed up the serializer, but I don't really care that heavily about the serializer. So I thought of a plan. What if instead of the instances being in a hash map, what if they are in, what if they're sorted by class? So like part, it all goes in a big list of parts. Wedge part all goes in a big list of wedge parts. And this actually makes the entire deserializer simpler. So instead of going through type info reference and then getting the instance is already there. It's in the type info instances. So it removes this unwrap and this hash map index for every single property here. It becomes simpler. And I was able to implement it, and it works. Okay, so here is the benchmark for master branch. This is the baseline. You can see it says it estimates it'll finish in 21 seconds. Cool. A little bit of spoilers there. Check out categorize chunks 2. Is there any new comments? Oh. What did I do? Assert. That's right. Whatever. Okay. It had a big effect. We're just waiting for benchmarks now. The micro benchmarks are actually slower though, interestingly. I think it's because of the big collect at the bottom of the file. It has to change from the type info owning the list of instances to then taking it out of the type info and into a big hash map. So it has to move all like 40,000 instances into another data structure. I think that's slow, and I have an idea for how to get rid of that. Yeah, so you see it's slower, 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 slower. The serialized should be the same. I don't know why it's not the same. So this is probably like the run-to-run variants. But yeah, what the heck? But then now we see a clue. Okay, 1,000 parts deserialize is faster. Here's the serialized benchmark that we don't care about, that I already made faster. And here it is. How long is this benchmark going to take? It took 21.6 seconds last time. Whoa! 15.8. Performance optimizer. And I think I can make it faster too. So this is 32% faster throughput. 25% less time. So I haven't actually submitted a pull request for it yet. It's begging for a different architecture. I'm actually thinking about this now. Maybe I'll just go try to do it. So this thing, yeah. So I was thinking, how do I do this in a way that makes sense? So here it is, struct chunk iter, and we got r reader r. Oh no, stage r s stage s, and then impulse stage r read s decode, type situation, function decode 1, self, actually let's make the trait stage. Trait stage. Type next. Function decode. Myself returns result. Nothing error. And then let's see. Next. Something like this. So decode 1 will be like this. I do need to do into next here. Oh, stage state. Oh, this is the deserializer state actually. Do we care? Input. Should be all of this. Oh boy. Maybe this is inner error. I don't know. that I've written 100 trillion times. There's the real function, chunk decode. I don't know if I need this function. Wait, pub super. We'll see. We'll see. Stage takes 0 arguments. Okay. Yes. So we also have this. S inner error chunk order S okay, they say expected actual. I can live with that. Unknown chunk version. Can we adapt this? Oh, no, that's version, not unknown chunk. Oh, there is actually no error for unknown chunk. We can call this like unexpected chunk situation. Unexpected chunk actual expected that type of situation. So we can say unexpected chunk. And then, yeah, so we'll need to do a little bit of wrangling here. Into. Try into unwrap. Stir from UTF-8. Unwrap. Yeah. And then if we do into, I think that's good. Self into. Where Oh. Oh. Yeah. Right. S next. So we're gonna say where S next from S. Jesus. Constant pattern cannot depend on const generics. No. Really, Rust? It was looking so clean. Nor. All right. We can do if else. It's okay. Dereferencing. Okay. Binding is not living long enough. Ah. So true. Very, very true. Yeah, let's just go string. Uh-huh. Uh-huh. Okay. We have code! Okay! Problem is, you have to just know which ones are which. Actually, I think I passed this as arg here. We'll see. Okay. So that's decode 1. There's also decode until. Many. And then our deloop goes like this. I don't know. So it has two outputs. The final chunk actually. Okay, so there's two ways I could do this. I could always read one chunk ahead. Or I could always be one chunk behind. Because this decode mini ends up with a leftover chunk because reasons. So this looks decent. So these will then instead be littered around. Okay, I think I want super traits actually. So decode, there's two traits here. I can just have it be a marker trait. So where's that damn trait? Trait stage. So then we can say trait unique stage. Chunk, unique chunk. Chunk unique. Stage. And then chunk many stage. And then now I can split this in two. And instead of S stage, S chunk many, and S unique. So one or 0 or more of these chunks may exist. Exactly one of this chunk exists. I think I want optional as well. Um, 0 or 1 of this chunk exists. that's cool. I like that. This is like this. Okay, so why don't I split it up? So that way I can like describe the stage process here. Impl stage for metastage. So type next equals ester stage. Easy clap. Easy clap. And then easy clap. So easy. This game is so easy. This game is so easy. Yeah. I'll just do it like this. So this very concisely describes inherent associated types. Oh, I'm doing this. So concise. And then the decode, this is S. This is this. Wait, this doesn't need to be a reference. This is so juiced. I accidentally juiced this really hard. Is this allowed? GG. So then, hell yeah. Chunk unique. So, holy. Okay. Impl chunk optional for metastage. Marker. Implement chunk optional for this. Oops. I believe this is also optional. And then unique. End stage should exist. Dude, it's so good. Typestate. This is going to grow considerably, but that's okay. Decoding stage keeps track of which chunk is expected next. Look at that, minus 132. We're cooking big time. I knew it could get smaller. Decode many. Decode 1. I should call it decode. I guess decode 1 is fine. Okay, so how do you, what words do you use for 0 more or more versus 1 more? 0 plus 1 plus. I could say 0 plus. Or like 1 plus. This doesn't need to be a super trait. It can just be a marker. So stage plus decode. And that works just as well. Okay. Yeah. New. No. So new starts in meta stage. And yep. And I am not sure what information. Stage, meta stage. Why is this huge? Okay. Okay, what is this doing? Oh, yep. Okay, self chunk. Yeah. Yeah. Decode. Impl decode for metastage. Shocking. Okay, decode, self, and then chunk is actually chunk. and it's a get owned chunk, and it's not immutable. We're just gonna go like chunk equals chunk as slice. Chunk data as slice. Okay. Okay. Yes. 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 It's all coming together. Yes. Impl decode for Esther stage. Decode. It's going to look exactly like this, including this. And then impl decode for inst stage. Gonna look exactly like this. Guess what comes next? Impl decode for prop stage. Look at how beautifully it's coming together. Impl decode for PRNT stage. And you guessed it, impl decode for end stage. And I guess we can do the underscore here. Close it off. And then impl deserializer state. Oh. Oh no, it likes it. Okay. Whew. Okay. Deserializer state finish. Are we doing like that? We don't care. R end stage. R. We actually just don't care. Okay, so we need metadata. Oops, I didn't want to do that. I kind of expected this to be more messy, but the marker traits are like giga. So tree reserve ain't need to do all that, and you ain't need to do all that. What do you mean tree? We don't have the shared strings yet. You're getting ahead of yourself. Okay, so we by we I mean me. Yeah, metadata. Yeah. So metastage contains metadata, and then we drop it right away. Yeah. So eventually we'll have all of this, but right now we only need this. It is dropped immediately is dropped immediately. Yep. XD. Metastage new. So we can implement a stage. Why don't we default? I think that'd be easier. Okay, and then, nah. No. Input. Yeah, just chuck her in there. Get her done. Can we say self? Yeah. Okay. Okay. So all of the transitions are done with into, right? Yeah. I think that's okay. Ooh. God, it's cooked so hard. Okay, so we have the first stage of decoding. Let's actually go write the deserialize implementation here. So this is not how it works. Deserializer. Uh-oh. Oh, I need the trait in scope. Do I? It's a method on the goob. It's decode 1. Oh, it's not public. You goob. Hold up. So the trait bounds aren't satisfied. It wants the next stage to be constructible from the current stage. And I haven't implemented that yet. Oh, I forgot the prop stage. Okay, Esther stage. Where did the big list of all the yeah, no, I deleted it. So shared strings. Yeah, baby. XD. Does it let me do that now? Its trait bounds are not satisfied. Okay, which trait bounds? All right, what's the order? Help. There it is. Give me that. That. Okay. Many, one. Yeah. Okay, so I also need a decode optional. Which sucks. That sucks. I guess I can just do this. Holy. Trait bounds were not satisfied, so ester into God. Yeah. Yeah. Okay. Next. This is going like beyond well. Wipe. Put it onto the. Did they do the map stuff? Let's go. Map fix is getting released. Let's go. So the time wipes need to be put onto the map tracking here in the pending time wipes, it needs to be very, very strictly organized. But like, yeah, add it to this as you go, and be very careful. You can also ask Redace to review it and stuff. Needs to be very carefully tracked. I feel like this is kind of in the way. Okay, so from Esther stage for inst stage, yeah, I'm gonna need this back. Let's pop that right there. Type infos. I think we have this. Inst stage. So we go. Yeah, so we need to with capacity to do. Okay. Inst stage db. Is that allowed? Oh boy. Deserializer database classes. So, so I could put the deserializer into the stage, or I could implement the decode trait on self. So is that the only spot? Oh wow. There's two. Maybe I actually throw it in there because it kind of doesn't need it. Um, no default, no default. So now I need new. Or I could just bop it here. Yeah. So then what up? Yeah, okay. It's gonna make me do that, isn't it? Do you like that? Okay. Vec. Okay. It's not gonna work. I'm gonna need lifetimes on some of them anyways, so it's whatever. Underscore. Well, with lifetimes, it doesn't look as nice. $11 more map fixes. You guys are doing a crazy amount of map fixes. Does that work? Yeah, no, okay. Decode for... Actually, this is... Oh, I see. Deserializer. State. Read. Should be like this. It's a bit less clean. But it comes off here. You actually don't need anything after the prop stage, which is kind of crazy. So you need all these in the prop stage. And then plus you need, oh, no, that's it. Yeah, so now we do this. So prop stage from instance stage. What do I call this stage? I think it can kind of just split it up. Ay, 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 ay. I actually think that I can underscore this in both spots. We can lose the type info stuff. We have to gain this. Can you increase the limit? I can. I don't know. I feel like you should work through the map fixes that you've submitted with the map council, and do them in a controlled manner rather than just submitting 100 map fixes. And then it's a huge amount of work for the map council, a daunting task. I think sort of like inching along is probably a better process. Like you can still make the map fixes ahead of time, right? And then submit them as the slots become available. It's not, it doesn't prevent you from doing the work. The limit exists because I didn't want people to hack the back end and submit a million maps and just like explode the database and like DDoS my server and yeah. New. What's this? Meta stage. Yeah, okay. Isn't this real? Oh, I see. That's the way it goes. All right, so where are the rest of the errors here? Yeah, jeez. Yeah. Um. No, it does kind of belong there. Stage. Looks like I didn't do that one. Hmm. So actually the input, actually, hammer it. Holy smokes. Ah. Yeah. Oop. Okay, what stage is this? Prop stage. Very close. Right. Da. Um. Wait a minute. Wait a minute. Wait a minute. Where build? Where do build? Build. 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 No. 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 Reserve here. Tree new. Meta stage decode. Did I? Oh, I just left it in there by accident. Decode optional. Ooh. Uh-oh. Oh, there it is. Decode one. Who's trying to decode one? Esther. think it's optional. Whoa. I see. Okay, so see ya. Uh, yeah. Oh, obviously. Homely momely. Tree. Make tree. Tree where tree. Tree where tree. Help. Tree where tree. Cook mega hard tree. 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 Uh-oh. Private. God. Oh, come on. Trolling? Trolling? Is it trolling? Associated type is private. Oh, the trait needs to be public. Oh, freak. Okay. All right, what do you want? Chunk mini is more private. That's just fine. Whatever. Like, whatever. code is more private. Like, relax. Relax. All right. All right, I'm saving this. Jeez. Crazy hard cooking. Okay, so let's see how we've done. Lots of lines added, which is expected. I expected it to be billions of lines added, and it would just be like horrible, but this is like clean. Oof. Okay. That's so cool that it's like kind of going through the properties there, because that's basically what it's doing. Only some properties are needed sometimes. Okay, so I think I need to bust this into the state. Num types, num instances. Yeah. Yeah, yeah. So that's init. So Esther, we just need to plumb inst type infos. It uses it. Yeah. It uses it right there. Um, yeah, no, it needs to happen like that, doesn't it? Oh. Ah. Should I just go blast this out as U32? It's smaller. So what did it actually say here? Instances by ref is +1. And then tree is reserved by num instances. I need to blast this all the way to the end. Actually, I can use the capacity off of this field. Instances by ref, instances by ref, instances by ref. It's there. Capacity. That's actually not quite correct. True. Yeah, so which chunk bubbers are optional and which are not type situation? You could implement the header as a stage. I might just do that. Right, there's a whole unimplemented. I kind of want to make a header stage. New. Yeah. And then I get to use the chunk unique. That's hilarious. Okay. That's actually hilarious. We can't actually do it like that. Never mind. Unlucky. Okay, set upstream, please. Okay, so it don't be working. Because I didn't make it work. So there's this sort of question of optional chunks and what happens surrounding that. Is there documentation here? Chunks. Wow, it's chunks. Aha, 0 or 1. 1. It's documented. Get documented, idiot. Okay, so there's the documentation. Here is the implementation. So meta 0 or 1, shared string 0 or 1, instance stage 0 or more, prop stage 0 or more, chunk many, print stage is unique, and end stage is also unique. Wait. Weak down from end stage. So do we need anything out of the stage? No, we don't need anything out of the stage. Dude. Is that loud? Oh, this game is so easy. And then there's no finish. We just finish with a DOM. Oh, come on. That's what you wanted. Deserializer. Oh. Rah. Insane. Yeah. Insane. Okay, so we match the documentation. Match the documentation. There's no more unused functions. How do we deal with the chunks? Why did this get wider? What happened? Pub super. Oh, hold up. I can actually do better here. Oh, come on. Here? What? Oh, obviously. Okay. Oh, and this is wrong. All right, time for some plumbing. I can't believe how well this worked out. I think I should write these side by side. Yeah. Decoding stage. So if we go like this, stage, I believe this should be this thing. Like, I think that is way clearer. And then stage. So, crap. Stage, obvious. This is kind of up here. I really didn't want to do that. Okay, so meta stage, shared string stage, So now where should I put these? I think under everything. Okay, I believe that is clearer. So we have the stage structs here. Yep, so each one has slightly different data. And then marker traits, nice and concise, optional, many, unique. And then the like, is that not like super nice looking? And then plumbing, stage, state plumbing. Okay. Okay, well, let's look at more. Deleted code. So the red lines are deleted. So we're looking for stuff like this, where it's like reserving capacity for stuff. I'm looking for that in like other spots. Metadata reserve. What happened here? Oh, stage. Deserializer class. Bruh. Wait, did I change it? Wait. Didn't I change it? Input stage. Input. I changed it. It's on here. I can put it back. Where was the mega cooking mega hard? Right here. Yeah, cook mega hard. Cook. All of them are cooking mega hard. Down. Read, deserialize state, decode for so this one, I want to like revert this. I'll just manually do it. Stage.decode. Stage.decode. And then instead of self decode, the stage decodes. And then Now we need to write that for all of them. Decode. We don't need the stupid read thing. And we also can just like chill with that. Yo, the Empire is pretty chill. And then we drop the database. Oops. I'm going to skip this because it's freaking long. And then, no. No read, please. Ah, yes. And now self.stage goes back. Jesus. Where other one? Oh, it's gone. There we go. Isn't that beautiful? Impl decode 4 in stage. Just decode it. Duh. Minus 94. All right, let's look at the diffy. So you have to construct a new one. And then decode for meta. Should I do chunk data as slice? Or should I do a special chunky man? Slice. I don't know. Love how small the diff is. Look at prop stage, no changes. It used to like mess everything up, and now it doesn't do that. Wait, am I done? No. I have to deal with the chunks. We only make the tree at the end. It doesn't just sit there consuming memory. Holy moly. Okay, so... Decode for meta stage, decode for searching stage, decode. It's so easy. The game is so easy. Oh my god, bruh. Prop stage. This is huge. What is that, 1,000 lines of code? Yeah, that's over 1,000 lines of code. And then parent stage, decode. It's so hard to not call it print. Oh, root instance refs. Did that ever get bubbied? Does it know anything about that? No, it doesn't. No, it doesn't. Okay, that's okay. Yes. Yes. Infallible. It's infallible. I love type signatures and type state. I cook this so freaking hard. This is nice and small, and then all of the like stuff is here, and it like should make sense. Okay, I needed to do this, and I'm not super sure. So you end up with a dangling chunk after you do your business here. There might be a chunk from the last time around, is what's going on. What if I also pass a chunk to next time around? That would be external here, and I'm not so sure that's a good idea. I could make it always decode 1, and then it's non-optional. No, I can't, because it has to go to the last stage. Well, I could. Oh, I actually did this wrong. I now realize. So this, we don't want this. We want it to go back. Oh, back. Yes, I know. Um, Wait, what? How do I do that? I want it to become none. This is kind of dumb. So I'm kind of struggling with this because of the like optional nature and decode mini. So if we look at this one, decode mini, let's say it's the first chunk to decode, and you expect there to be 7,000 prop chunks. Wow, there's 7,000 prop chunks. So you open up the deserializer and start and call this function. That's the first thing you do. So it decodes one chunk. Now it has a chunk. And then while it sees prop chunks, it goes and decodes them. And then chunk equals decode. Uh-oh, it's not a prop chunk anymore. Now you have this chunk sitting here that's not a prop chunk. What do you do with it? Well, now you have to go and pass it to the next next stage. Why don't I change these D underscores to say stage? I think that would be prettier. Look at how nice it is! Look at how nice it is! It does the same thing, except it's not JavaScript-y. Okay, so why don't I implement it as an optional, and then what's the size? 32. Okay. So okay. Decode 1. Yeah. This is like it's just a little bit janky, right? Because we're gonna do match self.next chunk. And if it's none, we're decoding a new chunk. If it's some, that's our chunk. And that's like, and then next chunk is always none, because we always consume one. So if there is one already, we consume it. If there's not one, we decode one and then consume it, or error. So we always consume the chunk. And then this one. I think I can invert the loop here. We always end up with an extra chunk here. Ooh, not looking good. Yeah. So if I do it like this, then we always have a next chunk. And that's okay. It will work, but is there a better way? So decode optional. You see, everything is starting with this optional, and that's like, so now it's just like this, except we don't fail. instead we just pass it through like this. Okay, so this is the else case. Oh, haha lol. Yeah, this is gonna hate me. Moved here. Chunk optional. So chunk is not optional. We beep 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 beep. I guess we say next chunk. Next chunk equals none. Some chunk. And not mutt. Cool. Okay, that should be the precise logic. Yeah. I'm gonna smash it into AI and see if it can think of a better way. Is there a way to write this without option chunk? This is the call site. Okay. Go AI. Go, go, go. Okay, what does it hate me for? Self. Next chunk. None. Name. Change var names. Implement chunk overflow carry. Go AI. I still got that. Chunks peak. Chunk iter. This code is ass. All right, I think I can finally test. Cargo test release. I expect it to fail because like it's pretty involved. Whoa! Pass. Okay. Success. Woo! The rewrite is done. Okay. I rewrote it. Plus 300 lines of code. 300 lines of explicit code. Should this go at the bottom? This is like not that bad. Read next. All right, let's. This code is ass. Yeah, the chunk iter ass. peekable chunk iter. No. No, 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 no. Okay, so I deleted the next chunk function. So I can actually bring that back. Let's bring it back, baby. Oh. But the loop won't want it. I'm not super sure about this. I feel like it should be a little bit different. I was thinking like I go into something. Yeah. Cause like I don't like the from this being a from impl. I think that's cringe. But it will still be a from impl, even if I make it a new type. Okay, if I make no. This could be finished. Yeah. Okay, let me try to make another stage here. Um, I guess it goes into the impl, but that's where it is already, and that's why I was saying I didn't want it. Gah. Finish. Okay, I was thinking tree goes into the So let's see. So it would reserve, and then you'd finish. I do believe. Oh. Um, yes. Okay. So no such thing. We just do into. Um, and then finish. So let's try it. So from end stage for final stage. I guess I should call it finish stage. Um, um, I think I want this. And then this goes here. And then it's just those two. And then I can grab from here. So then finish stage. Good. Ooh, yeah, there's a lot of stuff I could do here, but I want to keep the convert simple. And short and sweet. And then the finish can actually be a finish. This should go here as well. So then serialize state our finish stage. are. So does not matter. Oh. Yeah. Stage self.stage. I can mutt like this and go like that and go like this. Whoosh. Does this still work? Finish. There we go. Okay, so that looks a little bit more like the code that was already there. It adds a bunch of code, but it's a little bit more proper. All right, do I have any clippies? No. So now this matches everything above. For the most part, the new code goes here. You can't new with capacity, can you? You just have to reserve. Huh. Huh. Additional. I have just realized that it is actually over allocating, but that's a problem for a different pull request. Question. Oh, actually, this guy is here. Push. Yeah, let's reserve. Why not? Okay, let's look at the overall diff again and see what it looks like. So down here, we have self, deserializer state. So I don't want to have a separate function to pull out the stage. So I think I'll leave it like this small diff here. End stage, print stage, shared strings reserve. That's a sort of gratuitous optimization, but I wonder if we gain anything from this. I would very much expect not. It shouldn't be a loss either. It should be like a no op. All right, so let's do a baseline bench. It'd be neat if there's a little performance improvement, but probably not. Because it's at the chunk level, and the real performance is at like the property level. The number of chunks is insignificant compared to everything else. Dude, it passes all the tests. Holy. It's cooked so hard. I wonder what the optimization will look like on top of it. Oh, did I reserve the metadata as well? Nope, metadata reserve is there already. I'll make it look like that one. All right, git fetch. And then we check out this branch. Cargo bench. Sent what I downloaded. Are you sending me? The database won't go boom. It's actually a direct download from Roblox, so no skin off my back. Is that the right saying? It yeah. No, actually, it is proxied. Never mind. Why is it -3? I wonder if I forgot a pre-allocation. Okay, so it's plus or minus 3%. But this should be like totally flat. There shouldn't be any performance difference. That's what they all should look like. $21.6. Cool. That was the last time. That's how I knew the number. Okay, so there's no performance change at all. I think I may sit on this for a bit longer. I don't like the next chunk thing. I think it's necessary. Holy. %. All right. This is I gotta be able to clean up this a little bit. Um, I I can't believe how hard this went. We get the 4cc in the next stage. Holy. Wait. I could put these into next instead of using the into trait. That it would make it a tiny bit smaller, the code. But this wouldn't be as nice. So up here, these would be implied as well. Maybe that's a little bit easier to digest. Let's check it out. What happens if I do that? I gotta see it. Okay, so this is a function into next. Oh, I still need the type next. Self next. And then where will we these functions stage for meta stage into next. Boom. Ooh, that's nice. Can I say this? Damn, that's crazy. And then this goes here. Right. I'll just grab all of them fast. Yes. So now I get to say self, which I like quite a bit. Right. Unlucky. Yeah. So like that's nice. It's nice that this is smaller. How many lines does it save? Uh, compress. Ooh. 21 lines of code saved. It's like smaller. Okay, so I'm wondering if this should go at the bottom as well. Because this builds on everything above it. Right there. And let's see how that looks. Okay, so meta stage, the instance stage, the prop stage. You can see it's like kind of going together, and then yeah, holy, holy, jeez, and then we have the deserializer state, stage, decode, decode. Damn, that is so cooked. So smooth. Okay, and then the only thing you do in new is decode the header. There's no freaking giant allocations everywhere all the time. I did want to have a header stage, but it necessarily wants a chunky boy. I could just call header or something. I could have like empty and then call header. Ow. Like dot decode header. That would work. But that would mean another stage. But no, actually it wouldn't mean another stage. Alright. Input. I don't know. Maybe it would be cool. Like, you would just construct. Yeah, no, I don't know. I don't know. This would be like empty struct. I think it'd just be bloat. You do like dot decode header. It would look like this. You go like stage header, and then you go let stage meta equals stage header dot decode header. Do I already have crap? No, I don't have any crap. Let me look at what it looks like if I do it like this. Okay, so new, no mut, and then stage is boom. We don't. Oh. Oh. Yeah, it doesn't really make sense. So like, this is kind of cool. If we do R, and then we can do like pub function decode header. Self, and then this crap. Right, but then we need our read. I guess mut self dot input, and then we do okay. Input. Shack Attack is so good. It's crap. It's still huge. Oh, I need to, okay. It like, huh? Why do you need the deserializer for the header? The trick is you don't. You know what would be cool? I think this is stupid. Let's do cargo. It's like plus. We don't do plus. So what would be cool is if you could inject state. I wonder how crazy that would be. So like, if we look at this, the deserializer is literally just sitting here until the instant stage and prop stage. And what about the header? What is a header? Header. What do you have? Oh, literally that's it. Okay. Well, actually, holy. Okay, that actually makes things smaller because that's like exactly it. Um, it's the file header. Uh, okay. What's on my thing? Okay. Oh. Oh, jeez. So then it stops. So what do we grab the header. And then we can also do this. Header. Yeah. And then this is header. Straight up, it's the header. Yaha. It's Clippy with 3 P's. All right, we're good. Minus 17. Easy. Juicer. Let's look at the sizes for fun. So first one, metastage, 80 bytes, 40 bytes, 168, 232, 96, also 96, 240. Isn't that cool? It's like sometimes you need data, sometimes you don't need data. It change every single stage change except for the end stage. Every single stage changes. So I could like inject the database into the instance stage, but like I would have to like make some stupid data bags for the decode functions, and it would all get worse. So meh. I feel like this is like heroin for Rust you see this and you're like, oh, that's good code. Okay, 315. I actually got the line count down a little bit. That's kind of juiced. I like how the needed values are not necessarily in order. Oh, I love how this value is dropped as well. That just makes me so happy. Like it needs it to duplicate, and then it doesn't ever need it again. So it just goes away. It's done. I think this is poorly named. Unique chunk 1, chunk optional, chunk many. How do you say, what's a good word to say 0 or more? Hmm. 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 You know what? I think this makes more sense right here, because you can actually see the traits there. So before it was like kind of stuffed in between, but like where are you gonna be looking? You're probably gonna be like pasting. It's kind of everywhere. If the expected in chunks decoded by this stage. The next stage. And then into next, duh. What was I talking about? Oh, I moved this code. That's where does that go? Like, it's the juice. That's the juice. So previously it was here. I think that's good. Because like you just defined the stages. Now which stages are which? Optional, mini, multiple. Required. So that doesn't say whether multiple are allowed. So exactly one. What are better names for these traits? Hail. Make better AI help. Help. Chunk multiple. Wait, did I call it multiple? Repeatable. Singleton. That still kind of like allows for optionalness. Yeah, this is like 0, 1, exactly 1, 0 or more. That's like multiplicity. Holy. Wait, and then I could like have a trait bound. Is that allowed? Where multiplicity equals. I don't think that's allowed. A specific value. I think that's only for types, right? You couldn't like grab a value. Yeah, no, that's like runtime. Okay. Okay, so multiple nor. 0 or more. Optional 0 or 1. But now it's like optional is good. Multiple, optional, multiple. Singletons is not exclusive. So like, okay, singleton is bad. Repeatable. Repeatable's not bad actually. Could be better. So optional is perfect. There's 0 or there's 1. It's perfect. Chunk exactly 1, chunk multiple. Yeah. Required. Required sounds like 0 or more, or 1 or more. Required sounds like 1 or more, but it needs to mean 0 or more. Repeatable is unclear. No, it needs to mean oops. It needs to mean exactly 1. Stop. Required sounds like 1 or more, but it needs to mean exactly 1. Repeatable is unclear. Single. Unique. Unique is what I had. What about repeated? Chunk repeated. So repeatable is like, oh, so you can repeat it. Great. Repeated is used in Golang for, no, it's used in gRPC, which is like Golang. Go cheese, go cheese. I just don't want that waxy flavor. Some may like it, but I do not. I like my cheese cheesy. Cheese. Yes, cheese. Yes, please, cheese. Chunk 1. Chunk once, chunk repeated, chunk optional. How about this? Are any of these unclear? Now I'm asking for AI's opinion. Compare and contrast. It's fine. It's fine. I'm fine. Once repeated can be ambiguous. Once or at most once. Right, fun once. Yeah. It's just a little bit harder to read, honestly. Hmm. Oh, look. Chunk once, decode one. Chunk repeated, decode. Should I call it decode once? It actually works. Damn. Okay, my naming I think is good because like decode once, yeah. Decode repeated, yeah, that's what I mean. Decode repeated, decode optional, that's what I mean. Decode once. This is exactly what I mean. I think this is very clear. Hmm. Yes. Decode once. Yeah. Yep. Decode optional. It's built into the type system. You know, I do be doing it like that. I do be doing it. All right, mini unique, garbage. Repeated once, fine in context. So like right here, perfect. Repeated, maybe you wouldn't know whether it's one or many, one or more or zero or more. Loving it. I can't believe how well this turned out. Three traits is a little bit crazy. But it's to help cleanly separate them and keep the sections tidy and minimize the diffs. Because like I could put decode onto stage. But then I would need the decode implementation to go into the stage impl. So I'll just compose them together. Wait, is it underscore chunk? Hold up. Hi, I am writing uber amazing code. Yes, it is underscore chunk. Okay. This should be renamed to chunk. Mm-hmm. Because you're decoding chunks. Crazy. So like, yeah, it just makes more sense. Mutt. Wait. Right. Okay. Deserializer. So I was thinking like, doesn't it mean that you can like reuse the deserializer and it's in like a bad state? But no. Inst stage, prop stage, print stage, it's parent. End stage. Wow. Isn't that like juiced code? I feel like there might be a way to make this a bit smaller. Let me like smash it through again. AI. Make this code smaller. Yeah, it knows. Imagine it just removes all the spaces. White space. Next chunk, impl decode. It's like mega obfuscated. Those are the pieces, but mutt chunk, not all of them are mutable. You can't do this because you have to do that. It's not better. I'm not a good prompter. I can't like torture the AI and like you don't need a take, man. Finished. Not quite the same. The logic is like just different enough. So like, yeah, this code is exactly the same as this. Oh, it's actually not the same. Only this code and this code are the same. I can D this. But this one is mutable. So like this code has 3 copies. But how do you like take advantage of that? How do you do that? Oops. Insane. Should I call this deserializer stage? No, it's kind of verbose. Just make sure. All right, we still pass. I love staring at my code. So it says unknown chunk, but really it's unexpected chunk. And I made a special error for that. Oh, there's also the unwraps. Right. So finish should also make unexpected chunk. Wah, wah. Unexpected chunk. Unknown binary chunk name. So basically, it'll just say unexpected chunk. and that covers it, and it doesn't check to see if there's data past the end of the file. But it does in tests. Sheesh. 317 lines of code. It is purely a increase in lines of code and a duplication of code. Like these stages have like duplicate elements between them. Whenever it has to like pass it down the chain. Sorry. Oh, input. Right, input is on the oof. God, it's so strongly typed. I'm so strong at making types. Deserializer, and then we don't need it anymore. Okay. So now I should try to build the other feature on top of this. Oh. Jeez. I'm going to lock my 30% speed boost pull request behind this pull request. To be like, see, it's useful. See, Typestate. The guy directly said that they don't care about line count. I find that kind of hard to believe that a human could not care about line count. Oh, you're bloating the code. Huh? I thought you said you didn't care about line count. Thus far it's been true though. Breaking changes that don't add anything, of course, are not accepted. And this is not a breaking change. Huh. I could bake the chunk into the stages and hard code it. Because it's not optional when the repeated stage is previous. I don't see that decreasing the code size though. So like I could make it like more type state where like it becomes not optional and then it becomes non-existent sort of thing. Oh, it's always some or always no, okay. Okay, it's only optional when interesting. I could totally type state it and then remove like 3 if statements by adding like 16 lines of code. I'm a little bit curious. Yeah, so I would say C. And then trait get chunk. Yeah. Oof. Oh. Ah. Input. Yeah. Get chunk, get chunk, get chunk, option chunk is this. Uh-huh. Right. Uh, oh, I guess I can do here. And then that's easy. Are you allowed to do that? Evidently not. And then we actually don't care at all. Self input. Oh, really? Okay. Sid. Wait, what? Oh. Incompatible type for trait. Oh. What the hell? Whatever. Oh. True. Yeah. Okay, and then, yeah. Yeah. Self. Yeah. Get chunk. RSC. Holy. Okay. And then this becomes chunk equals self the next chunk dot get chunk. Mutt input question mark. Oh, self dot input. C. Oh, actually, it's like this. It turns it into that. Okay, so then this one also, we save 2 lines of code, 3, and this turns into always none, i.e. nothing. C is get chunk. C, and then boom. C get chunk. Well, we do a little bit of trait. Oh my god. And then this is chunk. It is there's definitely a chunk there. There's always a chunk there. Okay, then what about this? What do you hate me for? Oh, okay, well, no, C, it doesn't matter. We don't care. C. Oh. Yeah, no. It starts with nothing. Jeez. Holy. Now why do you hate me? Deserializer state finish stage. Is it like this? Okay. Get chunk is more private. That's just unlucky. All right, so I saved what 9 lines of code by writing all that. It's technically faster by a few instructions because it monomorphizes on every single line. So on the first line, it definitely doesn't have a chunk. So it always decodes a new one. The second line, it's optional. It monomorphizes to optionally decoding a chunk. Then this one, also optional, monomorphizes. Also optional, monomorphizes. This one, also optional, monomorphizes. This one, it never exists. Look at that! Look! It shows you what it is. Wait. Chunk. Oh. Whoa. Oh, result. Okay, C. Chunk. I was wrong. So this is option chunk. This one is always chunk. Damn. That's overkill, but correct. Little whiff of mold. Actually, kind of like it. This is overkill. Jar milk. It's true. I'm not sure if I should commit this. It's a little bit crazy. But like it's accurate. And it actually is kind of what I was thinking about at the beginning. But realized all decoders should look like this. Maybe not. There might be different stuff. Get or read chunk. Take or read chunk. XD, 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 XD. Okay. It's like, it's technically better, but it's like complicated, so. And what, it saves like 5 if statements at best? Throughout the entire execution? My 5 if statements. I'll call it next chunk. Um, 85. Omega lol. This is so huge. But like trait bounds are so powerful. I want trait bounds for everything. You get trait bounds. Stop being inside. There's a bug. It's on the camera. I'm trying to kill the bugs. Wait, you're allowed to not R? Do not R. R. Wait. Wait. Where's it? Here it is. Chunk decode. Ha! I could totally do that. Okay, watch this. You've never seen anything like it. Amazing. Isn't monomorphization great? I mean, it's so unreadable. Oh my god, bro. Yeah, I can't do that. That's unreadable. Like this is decent. Oh, the unwraps. Ooh. So this is only going to happen if you have I guess a malicious file that you don't want it to panic. I could just smash out an unknown chunk version. Oh, wait. What do they do about chunk name here? Do they leak? I don't remember. Oh, they just log it. Sure. I guess I could just log it. Um. Yeah. Okay. Oh, ow. Um. Wait. Um. Oh, unexpected chunk. Yeah. Let's go like this. And then we'll put this right here. Inner error. Unexpected chunk. I guess actually I can own that. Because it drops the chunk. Expected. So we go like this. Oh, I can't panic. Rest. Why don't we do unwrap or default? Because, like, static. Oh. Um, um, cool. All right. So now I'll just say UTF-8 error. But I could have just added that in the first place. So I think I'm just going to add it in the first place. Oh. I hate formatting. I hate formatting. Oh my god. So we don't need this. No panic. So it'll just not tell you what it is. And like, that's better than breaking your software. It's very rare, but like, you don't want it to crash. Or I don't want it to crash. I might sit on this a bit. Hee hee, hoo hee hee hoo hee. Uh-huh. So plus 42, I mean, so what is that? 17 lines of code. If you had like 7,000 stages, this would be worth it. It's not actually that bad. Okay, what if I say the result is stdio result? Is that good? It's good. So if I do this, it hates me, right? Yeah. Am I allowed to do where? No, okay. God, I love this. This is a good explanation. I don't know. I'm curious. So that's a little bit cleaner there. I think this goes in. It's... Where can I put the decode chunk trait? Decode a chunk which may one chunk which not be present. Decode one chunk which must be present. Decode chunks repeatedly. How's the crawling going? I moved on to other stuff. I am working on the other stuff. Decode one chunk which may not be present. That's kind of a bad wording. Decode one chunk which must be present. Let's see. Did you see the yeah, you did. My cool visualization. You're gonna steal it, which is allowed. So I'm working on the decoder library for Roblox files. And I found an optimization that makes it 30% faster, which like, hell yeah. But it's screaming out in pain for a design change. And so I'm doing that design change. And this is the design change. So we can see right here. So this function deserialize. The old way was to loop and match the chunk name, and it would just kind of call functions depending on what happened. But there's actually a total order, an exact order that the chunks must appear in the file. And that's not reflected. This doesn't actually care if they appear in the right order. It'll just kind of like spew a random error if that's unrelated if they're in the wrong order. So I explicitly created a error, unexpected chunk, and made a crazy typestate pattern. Have you heard of the typestate pattern? Crazy! It's plus 250 lines of code. All right, I'm trying to choose these comments better. I wish it wouldn't show that. Decode one chunk which may not be present. It's like optionally decode one chunk. If it is present. Yeah. Okay. Decode one chunk, which must be present. Decode zero or more. Decode chunks repeatedly 0 or more times. Yeah. Monomorphizing the acquisition of an initial chunk depending on whether the previous stage produced a chunk which has not yet been serialized. I guess decoded is the word. Typo. Love, love, love. All right. A little bit crazy. A little bit crazy. A little bit crazy. But I think it's okay. We test those. Yes, sir. Yes, sir. Yes, sir. So how do I? Let me go test Roho. Because what if it doesn't work? Okay. Time is it? Woo! 4 p.m. I've been working for 8 hours, and it's only 4 p.m. Damn, I got up early, and I just like got to work. Fantastic! Yes! Get the work done! Do it! The more time I'm programming, the more happy I am. Yes! Shack Attack is here with me. Oh, it's infallible. All right, watch this. What if I call the wrong function? Decode string repeated. No. Excuse me, sir. Your trait bounds aren't satisfied. And it's like, you see this trait bound? In order to call the repeated function, you must satisfy the repeated trait bound. Yeah. It grows and shrinks. It grows and shrinks. $96. 232. 240. All right, why don't I write a little documentation here? There are 6 different chunk types, and they must appear in the file in a specific order. Period. The deserializer implements decoding using the Typestate pattern. I think that's kind of cringe. The relevant state for each stage is different. As the decoder reads each chunk type. Some state such as is only relevant for a single stage and can be dropped. Some state is such as unknown type IDs is only relevant for a single stage. 6 different chunk types. Whoa, 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 whoa. 6. Shared strings get dropped, Bubby. I wonder if this architecture works for the deserializer as well, or the serializer. It probably does. It's nutty generic. I won't need the next chunk thing. You can see it's already kind of implemented like that. So right here. Whoa! And that's kind of where the idea came from. So, wider. Yeah. There are 6 different chunk types, and they must appear in the file in a specific order. The relevant state for each stage is different as the decoder reads each chunk type. Some states, such as unknown type IDs, is only relevant for a single stage. Yay! Little blurb. Work in progress. Cook mega hard. Cook. Ugh. Yeah, no, this is cooking mega hard. Each function is turned into a trait. That's so good. I might learn something if I do the serializer. Should I sit on my changes? I want to do this tomorrow as well, and do the type state for the serializer. I might have more ideas and want to change both of them. This developed so well. Love it. This will be interesting to implement. I have 2 jobs left on this. One of them is to implement the optimization on top of this, and the other one is to implement this for the serializer as well. Cool. Well, I think I'm done. I'm going to leave it there. Eight-hour. This stream will probably be encoding all night. I'm so happy with how this turned out. This stages, it's pretty clean. It's only 300 lines of new code. I'm just mesmerized. Decode chunk. It's more like ingest chunk, but like we can keep it decode. The only thing I would want would be that this function would be on chunk optional rather than on as like just a marker. But it's okay. So now here you can hover this, optionally decode one chunk if it's present. Decode chunks repeatedly 0 or more times. Decode one chunk which must be present. It's documented. That's how it works. It goes like that. I really want to submit it. I should probably cook it a bit harder. As in, I should do all of the dependent pull requests before I submit it. Because I might think of more stuff to add to it. Damn, I cooked this hard. I didn't even need to import any traits. That's insane. Just as implicit. Holy. Finish. Let me look at the diff. I should probably just do this on my own time. Yeah. Mutt self. Deserializer state. Finish. Cooked hard. So good. I wonder if I should put it back as a reference. I think I should. Oops. Because... Hello? Because, yeah. Okay, I can F this. Borrow chunk to avoid. Yeah, borrow chunk. We'll go with that. Actually, we can go with the original signature. We don't need to do that. Okay, type in tray. What are you trolling? Oh, it's trolling me. Yeah, that'll actually make the diff smaller. So I can say this. I can put it back to the way it was. And then go like, yeah. And then yeah. We can return to the original interface here. Very nice. So, original type signature. And then that cleans up 10 lines of code. VV nice. Oops. Gotta make sure. Yeah. Nice. The amazing things happen when you reread what you wrote. Love it. So now it's much closer to the original signature. Maybe I should let me try this. Struct no chunk. Doesn't like that trait bound. Chunk, no chunk. Is that finished as well? Yeah. What does it look like? So it adds one line of code. Is that clear? Like this is like. A zero size type, which represents the absence of a next chunk. So then you can do next chunk dot next chunk or no chunk dot next chunk. Right here. That would unify the interface, but meh. Explicit no chunk type. Remember when I was talking about being done? Wait, plus 8? 8 line of code? Oh, I added a comment. Calling next chunk always decodes a new chunk. More documentation is better, right? So like if I put this here, Calling next chunk always decodes a new chunk. So then what about this? So if I say, hey, what up, dot next chunk, no chunk dot next chunk, I think that's not clear. It's still not clear what's happening. You need to see the documentation here. But like, I guess if you hover here, a zero type which represents the absence of calling us always recodes a new chunk. So I guess that's like quite explicit, but I don't know. It just looks weird. Like what? So like the interface is unified now. So this always calls here. Oh no, it's still there and there. Okay, never mind. I was like deciding whether or not. Comment. Explicit no chunk type. You must end up with no chunk. And like, what is that? You don't know. R is reader. You know that. Finish stage. Yeah, you're on the finish stage. What is that? Yeah, I think this is better. It compiles so much faster when you don't have to build the types and stuff. Incremental builds. Let's go. God, I love looking at code. Oh, should I do serializer and deserializer simultaneously? No, I should do them separately. Okay, I'm gonna do something here where I find all of the decode implementations. There's too much code. So all of them, okay, they're like here. Okay, so metadata, you can see that right up there. That's the only thing in the meta stage other than the header. And then ester stage, shared strings, int stage, deserializer, instances by a ref, type infos. This is not going as well as I thought. It's pretty cool. I feel like Rust would tell me if one of the fields was never read. So I think I don't need to check what I was doing. Should probably add a space here. Code header and initialize the first stage meta stage. Cool. There's a crazy small amount of changes here. Like you just remove that text and that's it. The code chunk is so good. Let me look for this reserve. That's okay. So it's not reserved. Okay, I'm done. I'm done. Stream over. I did it. I'll probably keep like looking and stuff. Maybe I'll write the other one. This was really fun. So glad I had that idea. It's strict. All right. I'll be back tomorrow. Tomorrow is Wednesday? Yes. I'll be back tomorrow. I'll work on the physics more. I've confirmed that the thing works. The new algorithm is perfect. I haven't observed any anomalies visually visually inspecting the output. What's it called? Like empirical evidence. I have an abundance of empirical evidence that it is perfect. It may not be perfect in some cases, but I don't know that. I didn't see that. So all of the problems must stem from face crawler code or Minkowski sum code. So I'm going to have to work on that. It's kind of the hardest part. Yeah. So I will do that tomorrow. Great. Good talk. Okay. Goodbye. See you tomorrow.